Welcome, welcome, welcome. Thanks for doing this. Let's talk about cloud computing, which is another word for all computing. I think part of this conference is to understand the consequences and the energy usage of the decisions we make every day. As we were planning this, I had some conversations with people that didn't understand why cloud computing would have any energy footprint. So Jennifer, maybe we start with you, and obviously Intel makes chips. Those chips go into computers that we all have, but they also go into data centers. And just try and give us a sense of the scale of the data center universe that is powering our everyday lives today.
Yeah, when you look at data center energy consumption, it's estimated to be 1% to 2% of global energy. And a little known fact that we don't talk a lot about, Dan, is the network itself. And that's another 1.5 times that much. And so it's not just the data centers that you see potentially in your neighborhood that are consuming the energy, the precious energy on the planet. It is also the network communication. And we're each tapping into that every day with our phones. The mobile RAN is the largest portion of that network consumption as well.
Is that right?
Yeah. So
more so than desktops and servers, it's coming in through the phones?
The phones. So you start to think about what choices can I make as an individual, and using your Wi-Fi, not using the cell. If you're streaming, those are individual choices you can make. But you go back to how many of us really think about we're spinning up servers when we're asking questions, of a search engine or searching for pictures in our feeds. So all of that consumes energy, and it's a really important part of the mission. We know computing, data centers, cloud is foundational to society and where we're going. And so that's really one of the main jobs that I'm working on, is how do we help lower the energy consumption of those data centers, and especially with the advent of AI, so that we can have sustainable computing for the future.
So Chris, you've got a company that actually is trying to answer that question and build more sustainable cloud services. Talk to me a little bit about Cloud Nexus and how you go about delivering some of those efficiencies.
So what we really look to do is help companies reduce the consumption to make the same amount, to process the same amount of data. But we also look at it from a perspective of location and time. Where you run that data set, where you run the processes, and when you run it has a lot to do with that impact of your carbon emissions. So if companies start looking to shift where they're running workload to, for instance, following the green energy, right? If you've got and I like to pick on Ireland because it's a really good example. They go from fairly carbon intensive to one of the cleanest regions in Europe based on wind, because they have so much wind and a lot of it. But it ebbs and flows, and there's been a lot of conversation today around the sustainable technologies, but particularly on batteries. So how we start looking at all that and how we start following that energy and putting those workloads, and particularly with AI, with ingestion and everything else, when you take in that data and when you process the information and where you're doing it, is super critical to reducing the amount of carbon that's being produced.
This was the example that I like to use, is that this is like running your dishwasher at night, where you've got energy prices during the day, they're at one rate, but if you run it overnight, you get the lower rate because there's less demand. You're trying to do that with data centers.
Exactly. The nice thing about the cloud is you can run your workload anywhere you want. Now, of course, there's data privacy laws and things that you have to take into account when you're doing it. But if you're running your workloads, if you're an East Coast company, for instance, right, you can run your workload on the West Coast in the mornings when it's 2, 3 o'clock in the morning, when there's very little demand. In fact, if it's Northern California, they're bringing a lot of hydro from Oregon and up north of there. So you're actually running clean. They've got a lot of wind, a lot of solar. As the day goes on, you can start moving that workload to back to the East Coast as the demand lowers. And depending on the company and where your data centers are, you can use other regions, Europe, so forth and so on, especially if you're a big global company.
Jen, in terms of obviously Intel designs the chips, and we've been following, I was in the PC industry before, following the way chips have gotten more and more efficient. They use less and less power. At the same time, we're building more and more of them and building bigger and bigger data centers. So what's Intel's strategy for reducing the overall energy footprint of these services?
Yeah, it's a couple-fold, and thank you for the question. I think a little known fact, because the Intel chips, and especially in cloud computing, have been pervasive over the last couple of decades. What you might not know is through the energy efficiency gains of Moore's Law and architectural advances, we've saved 1,000 terawatt hours in data centers alone, just through that energy efficiency. When we look forward, we want to make sure that we are embedding accelerators into your general purpose compute, and that's something to look for. Because you're able to run AI inference. Probably 65% of the world's inference runs on a Xeon processor today because it's so ubiquitous and available. Continuing to invest there, continuing to improve the energy efficiency. We have commitments in our RISE goals to improve those core products by 10x. But we also know that the world is shifting to this heterogeneous compute style, and where it's needed, having discrete specialized accelerators are really critical. And so we've been working on developing those products to deliver energy efficient acceleration. We just had some results published last week. If you're familiar with MLPerf, we were already reporting, this is our Intel Gaudi processor, it was 2x more energy efficient than the equivalent A100 from the competition, and the MLPerf results last week showed near equivalent gains on performance and energy efficiency. That's the hardware side. The other piece is on the software side, and so we have 10,000 plus engineers working on the software stack and optimizing it in open source, looking at one API, a one application programming interface that takes advantage of all of those hardware accelerations. Because if you really look at what's happened over time and with cloud computing, software has become really abstracted from the hardware. And if we go back in time, there were far fewer resources in your memory footprint, in your CPU. You think about what we sent on the Apollo mission. They did not waste an ounce of the resources. And that's something that I try to look for, and what I say is no transistor left behind. You want to make sure all this work and energy that went into turning that silicon, or the sand into a computer chip, make sure we're utilizing everything that's there, both within the overall data center utilization, which we'll start to see some reports coming out next year, thanks to the Energy Efficiency Directive in the EU, but also with that tighter coupling of the software and the hardware.
So Chris, tell me about the cost implications of trying to manage your emissions footprint on a cloud server. Are we talking, does it cost less? Does it cost more? How do you position yourself?
So it's interesting. I think one of the behaviors that we'd like to see change, and one of the behaviors that we're trying to drive, is that there is an actual cost to carbon, right? And this gets into where it's going with legislation and with policy, both at a government level and also as well as at a corporate level. But it's not going to be that long before IT departments have a line item that says cost of carbon. They're going to have to start including that into their budget because there's going to be a cost, right? And that's really what's going to drive behavior. One of the examples of late is there's a lot of companies, cloud providers are out there talking about how they're trying to get to net zero and they're carbon negative and this. And there's one of the big cloud providers is building a new data center in Ireland, picking on Ireland again, and they just got approved for 160 megawatt gas reactor. Gas is a power plant. So it's really the cost benefit of doing it with clean energy, and because of the storage issues, because of the availability issues, it still doesn't make it economically viable. So by applying a cost, whether that comes through on taxation or whether it comes through on the cost of the business impact that the ability to attract talent, the ability to attract customers. More and more people are aware of these issues, and they're out there looking at it. Do I want to do business with this company or this company? You look at what the cloud providers are doing, and some of them are taking a very big lead. We're actually really happy with what Google Cloud has done, with their sustainability, and we get that feedback from our clients and customers that they want to start looking at that because they're taking it seriously and trying to do more with it.
Yeah, just if I can build upon what you said, Chris. The reason they had to go look for that own generation is because power is the constraint for this insatiable demand for compute that we all have and all the new use cases that keep popping up. So that's just an example of
Absolutely.
them needing to solve that problem. And one of the other innovations that we're partnering on with data center providers and climate tech startups around the globe is liquid cooling. And there, we have an example in Shanghai with the university there with an HPC cluster. When you put in liquid cooling to dissipate the heat, you are avoiding the wasted energy of moving air to cool these servers, to cool the various chips within the platform. And on top of that, you're able to do it with no water. We don't talk about water enough when we talk about climate.
What liquid is doing the cooling?
There are a range of synthetic fluids, mineral oils, so there's a whole suite, and we're also encouraging the industry to innovate for better thermal cooling properties. There are certainly some today that we wouldn't want in mass scale, but that's some of what we push academia and some of these new startups to go do. But if you can save 40% of the energy, you're going to be able to fulfill the needs of society, whether it's the remote healthcare, whatever the use case is, or automated driving. And, it's a constraint that I think is going to be here probably for the next 5 years until, there's some more innovations that happen that alleviate that.
And if I can add to that as well, it's also a supply chain benefit. So Microsoft, for instance, has been experimenting or had experimented with submerging data centers. Again, it's just surrounded by water. They use a gas to cool inside the container, and it actually dissipates the heat much cleaner. It's much more consistent. So what they've discovered was you don't need any energy to cool, right? The fans, the cooling processes, it's all contained in that thing. But the life expectancy of the hardware increased 40%. So therefore, you don't have to go out and manufacture new hard drives, new CPUs for as much, right? You don't need to replace the equipment as often. So that entire supply chain of IT really reduces carbon along the whole way down.
It does, and you can even have energy reuse. So in that Shanghai University example, they were taking the heat now from this hot water, the cooling that's happening in a closed system, and heat water. Provide the district heating for that university, the kitchen, the dehumidifier. So lots of opportunities. As we think about sustainability in a circular fashion, it's really important for energy because it's such a critical resource.
I absolutely agree, and it's one of the things that we're working on is kind of an ideal data center where we're looking at, and it's been used several times today. So nuclear reactors, modular nuclear reactors. And getting into the water, right? If you have the excess heat coming off of modular nuclear reactors and stuff is enough to run a desalination plant, or it's enough heat to run a vapor gathering, moisture condensers and so forth. So that's recirculating that energy, using it. Otherwise, it just goes off in heat to produce the data, produce the energy to run these data centers and the excess. And it's all part of that big ecosystem to continually drive down not just the emissions that you're causing to be produced by running the workloads, but everything along that supply chain as well.
So I'm kind of a ChatGPT junkie. I've been using it for everything. And I know that it requires tremendous computing power, and I imagine there is an emissions footprint that I am not aware of. But how is the rise of AI and the fact that so many people are going to be using these systems now? How does cloud computing evolve in the face of these new applications?
I'll
ask both of you that.
I'll go.
Yeah, I can start. I think. I spent last week with all these data center operators, folks that are building the shells and the buildings, and they're all thinking about the technologies like liquid cooling as a mandate so that, it can be more energy efficient. When we look at the large language models, these over 100 billion parameters, right? I think we should recognize that the majority of the models aren't going to be that large. And, when every company is now thinking about how do I apply AI in my business? How do I use it to extend, upskill my sales force, to reach more clients, to get to a decision faster, to write reports was an example. One of the local New York customers, our companies was talking about yesterday. So each and every one of us for your company is going to have a different way to apply it. It could be for doing energy reduction. In a mobile network, if you're looking for the network traffic, you can, throttle down systems when they're not needed. All of those use cases, I think, are going to be pervasive, but they don't all require so much energy. And so as folks are embarking on this journey, I think what we're going to find is there's going to be a focus on data quality over quantity when you're feeding a model, so it doesn't have to be endless amounts of data. Really, what is the question if you're a legal firm that is required for it? So looking at less compute-intensive ways of running the models. So there's something called FP32. It's very compute-intensive and energy-intensive, but you can do something much more sparse with the int8 and get a very similar result. So where do you need that precision versus like that near precision? Some of those are questions folks need to think about. And then, of course, as we talked about, both with like the Green Software Foundation, the Carbon Aware Compute, where and when should I run the workload? Can I pause the job? Or does it need to be running when it's most carbon intensity on the grid? So I think those are some of the ways that it'll evolve.
Exactly. I mean, there's not much I can add to that, actually, because it's exactly what the issue is, right? Making sure that your use case, you solve for your use case, not everything else, and then just take the piece of the answer. It's understanding when and where to run it, and the ingestion of that data. I think we were talking last night, right? That some, ChatGPT is a year, 2 years behind in data, but as that demand for real-time, ingestion of information, especially news, lawyers is a good example. You need to know the latest cases that have happened. If you're using it to do news, media type report, you need to know what's going on right then and there. So that gets really super compute intensive, just from the data storage side, bringing in all that data, reading it constantly. So where you run that and when you run that becomes more and more critical.
Are there any savings in just delaying, because ChatGPT is super fast. It delivers answers within seconds. Would there be any benefit to just slowing that down? Instead of taking 3 seconds, it takes 10 seconds, and you can therefore load balance a little bit better?
It could. Again, depends on the applicant and the use case. As Jennifer said, really understanding what your use case is. I mean, if you're looking to write a legal brief, is 10 seconds or 3 seconds really going to change your result? No, right? But that also gives the ability, you have to worry about latency so much. So if you're running that workload, in Europe or on the other side of the country or in Asia somewhere, you don't need to worry about that 2 seconds answer back. So understanding, that's all part of understanding that use case. And then also where you're going to run it, harping back on doing it in an area that's currently has a lot of green energy to it, right? Because although we definitely need to move away from fossil fuels and all that, we're a ways away from that. We're going to be, fossil fuels are going to be with us for quite some time to come. So reducing as much as we can now, and then getting into that habit and driving that behavior of using it when. And this gets into a bigger conversation. So even if it's all clean energy down the line, now we have to start taking out, okay, if I'm running all these intense workloads, do I have to build a bigger energy grid to get the electricity there rather than, distribute it to computing? And I think, Jennifer, you kind of hit it on earlier, right? We're going to see, commoditization of the cloud, specializations. I can't remember the term used, but, there's going to be a lot of specializations and where you run that workload and when, and essentially commoditizing that end of it.
Yeah, local accelerators, I think we were talking about, or building accelerators.
Certainly, there's the hardware that we build, and I think what Chris is teeing up is, where you go for your cloud computing today may not be where you go for your accelerated enterprise domain-specific models in the future. Okay. So there's a lot changing in that ecosystem right at this time.
Great.
Yep.
It's a great conversation. Thank you so much for doing this. Give them a big round of applause.